Today I'll be covering Chapter 7 from the textbook on the stages of long-term memory, specifically on encoding information into long-term memory and then retrieving information from it. First, let's begin by formally defining the different stages in long-term memory. The first stage is encoding, which refers to the initial creation of a long-term memory. Encoding is about successfully transferring the information from short-term memory to long-term memory so that it can be remembered later. The phrase we'll use to describe encoding over the next few weeks is that encoding is about constructing memories, not about creating a perfectly accurate recording of what happened. The next stage is storage, and we'll spend part of a chapter discussing storage in 2 weeks. And then the final stage is retrieval, effectively accessing or recalling information stored in memory, which I'll discuss during the second half of today's PowerPoint. We'll begin by discussing some factors that affect encoding. So factors that affect the creation of a long-term memory or how well you can retrieve it later. The first one is the use of elaborative processing, where the basic idea is that deeper or more elaborative processing during encoding leads to better memory. One of the first questions that early cognitive psychologists were interested in was what is the most effective way of encoding information into long-term memory? If you think back to Atkinson and Shiffrin's model, we said that rehearsal is the process that transfers information from short-term memory to long-term memory. And so, the suggestion from that model is that the more rehearsal one does, the better the information should be encoded into long-term memory, and thus the better the information would be remembered later on. However, research began to show that this simple view of the effect of rehearsal was naive. Specifically, researchers began to differentiate between two types of rehearsal: maintenance rehearsal and elaborative rehearsal. Maintenance rehearsal refers to maintaining the information in short-term memory by simply repeating it, which typically does not improve the encoding of information into long-term memory. So if you just repeat a phone number to yourself 4 or 5 times, it's unlikely that you'll successfully transfer that information or encode it into long-term memory. That is, it's unlikely you'll be able to remember it later on. Here's a study that illustrates this well. In this study, participants were given a 4-digit number that they were told to remember, and then as a distractor task, they were told to repeat a word for 2, 6, or 18 seconds, and they were given various words to repeat for these different lengths of time. At the end of the study, participants were given a surprise memory task for these so-called distractor words. That is, in reality, the actual purpose of the study was to determine how well participants could remember the repeated words as a function of the amount of rehearsal time. Would they remember more words, or would they remember more of the words that they rehearsed for a longer period of time? Now, notice the type of rehearsal they did during this study would be an example of maintenance rehearsal. They were just repeating the words and made no special attempt to encode them into long-term memory. The finding was that there was no difference in the recall of the words as a function of the different rehearsal lengths. So, in other words, rehearsing the information for up to 9 times as long, if we compare the 2-second words to the 18-second words, doesn't improve memory if all one is doing is maintenance rehearsal, just repeating the words. So again, this study shows how maintenance rehearsal isn't effective at encoding long-term memories. Now, this doesn't mean that rehearsal doesn't affect encoding, just that the type of rehearsal matters. Specifically, elaborative rehearsal does improve the encoding of information into long-term memory, where elaborative rehearsal involves thinking about the meaning of an item or making a connection between an item and something you know. So yeah, when you think about the meaning of words you're trying to encode into long-term memory, for example, that's when additional rehearsal does improve encoding and memory. So again, the first factor that affects encoding is elaborative processing. Deeper or more elaborative processing during encoding leads to better memory. To demonstrate the effect of elaborative processing, we're going to discuss one of the most famous studies in cognitive psychology, one by Craig and Tolving. In this study, participants made one of 3 types of decisions about words which require different depths of processing. That is, participants encoded the information by paying attention to different features of the word. In the shallow processing task, participants had to encode the word based on its physical properties by deciding whether the word was shown in all capital letters or not. In the medium processing task, participants had to encode the word based on its acoustic properties by deciding whether the word rhymed with another word. And then in the deep processing task, participants had to encode the word based on its meaning by deciding whether the word fit meaningfully into a sentence. And then they were given a surprise memory test on the words that they made a decision on. So note that while participants were encoding the words, they didn't realize that they would have to remember them later on. They believed that doing the task was the true purpose of the study. So I'm going to give you an example of the 3 types of processing tasks on the PowerPoint, but I also strongly recommend that you do the demonstration on page 175 to get a better understanding of this experiment. So, in the shallow processing task, like I said, participants had to encode the physical properties of the word. They had to decide whether the word was in all capital letters or not. So they might be shown a sentence like, is the word in all capitals? And then they'd be shown a word by itself. And they'd have to decide, okay, is that word in all capital letters or not? That's the shallow processing task. In the medium processing task, participants paid attention to the acoustic properties of the word. So they might be shown a sentence like, does the word rhyme with hand? And they would be shown a word all by itself, and they would have to decide whether that word rhymed with, the last word in the sentence. So that's the medium processing task. And then in the deep processing task, they had to pay attention to the semantic properties of the word. So they'd be shown a sentence like, the miner extracted the blank. They would then be shown a word by itself, and they would have to determine whether the word fit meaningfully into this sentence. And so this is the deep processing task. So the key finding from this study was that memory was better for words encoded under deep versus medium and medium versus shallow processing conditions. So here we see the data from the study showing the percent of words participants recall correctly that they encoded under the 3 types of conditions. Again, we see the effect that the type of processing has on encoding. Deep encoding, does the word fit meaningfully into the sentence, led to better memory than medium encoding, what does this word sound like, which led to better memory than shallow encoding, what are the physical properties of this word. So to summarize then, the type of encoding matters. Deeper encoding, where you focus on the meaning of the words, leads to better encoding into memory than other types of encoding. The textbook goes on to describe additional factors that affect encoding, so make sure you are familiar with these. What I'm going to focus on in the PowerPoint is these last 2 factors. So out of these 2 factors, the first is the testing effect, which says that taking a test produces an improvement in memory for the tested material versus spending an equivalent amount of time studying it. That is, a great way of studying for an exam is to test yourself on the material. Maybe by, taking a 5-question multiple choice quiz on the material, or maybe by using a helpful study guide that your instructor provides, allowing you to test yourself on the topics that will be covered on the exam. Here is a typical study on the testing effect. So in the typical study, there are 2 groups of participants. The restudy group reads and later restudies a set of material. For instance, they might be shown pairs of words during the study like bed and pillow, and they're told they will take a memory test on these words later. Then in the next phase, they would be shown the pair of words again, and they get a chance to restudy the information. The second group is the tested group, which reads and is later tested on the material. So they too would be shown pairs of words like bed and pillow that they're told they will take a memory test on later. Then in the next phase, they would take a test on those sets of words. They would be given the word bed and have to come up with the word that it was paired with on their own. Finally, both groups take the same final test on the material. So both groups would be shown the word bed and have to come up with the word that it's paired with. The typical finding of studies on the testing effect is that the tested group outperforms the restudy group on the final test. So in this example, the tested group remembered more of the pairs of words than the restudy group, suggesting that taking a test on the material is a really effective way of encoding information into long-term memory. The other factor that affects encoding that I want to discuss in the PowerPoint is the effect of practice schedules. So students often ask me, how can I do better on the exams? The first thing I tell them is to study longer. But for some students, that may not be an option. You might work or have a family to care for, so you might only have, let's say, 6 hours to devote to studying for any given exam. The question we're looking at now is, what is the most effective way to organize your study time? Well, there are two broad methods for organizing your study time: massed versus spaced practice. Massed practice refers to when practicing is completed in a small number of long sessions. So for a hypothetical exam that you have 6 hours to study for, if you were to use massed practice, you might spend 6 hours studying for the exam the day before you take it, or you might study 3 hours the night before the exam and 3 hours the morning of the exam. So you have a small number of study sessions, 1 or 2, that last a long time, either 6 or 3 hours. Spaced practicing, on the other hand, is when practicing is spread out across a large number of short sessions. So if you studied 1 hour a day for the 6 days leading up to an exam, or 1.5 hours a day for the 4 days leading up to an exam, you would be using spaced practicing. You have more study sessions, 4 or 6, that last for a shorter amount of time, 1.5 hours or 1 hour each. Note that the total amount of study time in these two practice types is the same. You're always studying for 6 hours, but what differs is the number and length of practice sessions. Here's an example study showing the effects of massed versus spaced practicing on performance. In this study, the researchers trained British postal workers how to type. They had 4 groups of participants, which represented a continuum between massed and spaced practicing. The massed practice group had 2 practice sessions per day that lasted for 2 hours each, so their practicing was crammed into a few long sessions. The spaced practice group had 1 practice session per day, which lasted for 1 hour each, so their practice time was spread out over more shorter practice sessions. And then there were a couple conditions in between those two. So here are the data showing how many words per minute participants could type after various hours of practice. The top line shows the spaced practice group, the bottom line shows the massed practice group, and the other 2 groups are in the middle. What I want to focus on is participants' performance after about 60 hours of training. Specifically, people in the spaced practice group were clearly outperforming those in the massed practice group, right? People in the spaced practice group were typing at about 85 words per minute compared to only about 65 words per minute in the massed practice group. To summarize then, spaced practice results in better performance than massed practice, that is, studying should be spread out over many shorter sessions. So again, to apply this to studying for an exam, if you have 6 hours to study for an exam, the recommendation is to study for many short sessions versus a few long sessions. Finally, let's spend some time today talking about retrieval, or again, effectively accessing or recalling information stored in memory. As before, we'll discuss some factors that influence retrieval, beginning with the type of retrieval test. There are a variety of recall tests used in cognitive psychology, but these are 3 of the more common ones. The first test type is the free recall test, where a list of items is learned and must be recalled in any order during test. So participants are shown a list of items, given a certain amount of time to learn them, and then with the free recall test, they simply recall as many as they can during the test. This would be similar to a short answer question on an exam. I might ask you, what is the definition of long-term memory? And you would have to try to recall the definition without any sort of hint. Another type of test is the cued recall test, where a list of items is learned and must be recalled with the help of a general hint during test. So participants are shown a list of items, given a certain amount of time to learn them, and then with the cued recall test, they are given some sort of hint to help them remember the information during the retrieval test. For example, if you give people a list of words to remember, like apple, banana, pear, cat, dog, horse, teacher, artist, banker, on the test you might give participants the category names of those items, fruits, animals, and professions, as a hint. This would be similar to a fill-in-the-blank question on the exam. You're given some sort of hint or some preliminary information, but you still have to generate the information or the answer on your own. The last type of test is the recognition test, where a list of items is learned, and during the test, subjects indicate which of a new list of items were on the original study list. So participants are shown a list of items, given a certain amount of time to learn them, and then with the recognition test, they have to indicate which items they saw on the study list during the retrieval test. For example, they might be shown words like apple, strawberry, and grape, during the recognition test, and they would have to indicate which of these words was on the original study list. This would be similar to a multiple choice question on the exam. You're given the actual answer along with a few distractor choices, and all you have to do is to recognize the correct answer. Now, notice that the effective retrieval test type is purely an effect of retrieval. In each of these test types, the information is encoded in the same way. Participants are simply given a list of items to learn, but what differs is how they have to retrieve or remember the items on the test. Now, the type of test is closely related to another factor that influences retrieval, the quality of the retrieval cue. Retrieval cues are stimuli that aid in search for a particular memory. Let's apply this to our three different test types. Free recall tests provide no retrieval cues at all. You have to generate the information, so you have to generate the answer all on your own. Cued recall tests provide some retrieval cues, such as the category name of the items on the study list, but you still have to generate the actual items on your own. And finally, recognition tests provide the most effective retrieval cues. You see the actual item you need to try to remember, right? Nothing can be a more effective retrieval cue than the actual item itself. To reiterate then, recognition tests provide better retrieval cues than cued recall tests, which provide better retrieval cues than free recall tests. And accordingly, people perform better on recognition versus cued recall tests, and better on cued recall versus free recall tests. Here are some data from an in-class example I did one semester, showing that when my students had to remember the same words, but were tested using the three different types of retrieval tests, they remembered more words when they were given a recognition test, followed by a cued recall test, and finally the free recall test. So again, we see how the quality of the retrieval cue influences the retrieval of items from long-term memory. A final factor that influences retrieval is matching, encoding, and retrieval, where specifically a match between them generally improves memory. The textbook talks about two examples. The first is encoding specificity, which is when the conditions or physical environment match between study and test. For instance, your textbook talks about the study where participants had to learn a list of words either underwater or on dry land, and then recalled them underwater versus on dry land. The finding was that participants remembered more of the words when the physical conditions during encoding and retrieval matched. For example, when they learned the words underwater and then recalled them underwater. Another type of match is known as state-dependent learning, which is about the internal match between study and retrieval. The textbook talks about the emotional match between study and retrieval affecting memory, but I'm going to go over a more interesting example, I think, specifically being stoned or not. In this study, participants studied a list of words and were given either a placebo or marijuana. Then, during the test phase, participants recalled as many words as they could after being given a placebo or marijuana. So, specifically, for the two groups that were given a placebo when they studied the words, half of them were given a placebo when they recalled the words, and the other half were given marijuana. The finding was that the group where the internal state matched between study and test, those participants that were given a placebo during study and test phases, they recalled more words than the group where the internal state did not match between study and test. Now, you might be saying, hey, maybe smoking marijuana just impaired people's memory. Good point. Well, two different groups of participants were given marijuana during study when they learned a list of words. Then, when they recalled the words, one group was given a placebo and the other group was given marijuana. The finding was that, again, the group where the internal state matched between study and test, those that were given marijuana during the study and the test, they recalled more words than the group where the internal state did not match. This demonstrates state-dependent learning. A match in the internal state between study and recall improves memory. To apply these data then, I expect your performance on the exam to be best when you study sober and take the exam sober. However, if you're going to be high when you study, you better also be high when you take the exam. Okay, the final thing I want to talk about is some tips on study. I know it can sometimes be difficult to see how the information we learned in this course applies to your everyday life. So I want to take a minute and review how some of the topics we've been talking about this semester can be used to improve your study. For instance, we talked about the effects of dividing attention between two tasks, such as talking on a cell phone while driving, and we said that it impairs performance on both of the tasks. And so when it comes to studying, and whether it's a good idea to divide your attention between studying and listening to music or watching TV, the answer is no, don't do that. We got through discussing levels of processing today, where the recommendation is to use deep or elaborative processing strategies. So when you're studying, don't just repeat a definition you're trying to learn over and over again. That's maintenance rehearsal that doesn't improve memory. Instead, try to rewrite the definition in your own words. That encourages you to focus on the meaning of the information. We've talked about how information in long-term memory is organized by meaning, and the textbook discusses some studies that show an advantage for memory when the material is encoded in a meaningful way versus when it's encoded randomly. So the suggestion is to use chapter outlines or study guides to help you study, which should have naturally organized the information by topic or by meaning. And then on the PowerPoint today, we've talked about the testing effect, we talked about space versus mass practicing, and we talked about encoding specificity and state-dependent learning, and you can apply the information from those topics, obviously, to help you with your study. Okay, that's all for me this week. Good luck on the quizzes and exams, and as always, let me know if you have any questions.